not join. If you have any personal questions, just let me know and we can talk after. All right. Welcome. Thanks for coming, y'all. So, I think like 3 weeks ago, I went over this session 1 with Bobby and X, and I think they're going to join us at 6:30. But session 1 is really the basics, really fundamentals. Y'all will probably know most of it, maybe. Session 2, which we'll get into, that will have, we'll actually get into coding, and we're going to work on something called Google Colab, and that is basically like Google Docs, but we can run Python in it. So super helpful, especially for applications like this. That way, if you guys have questions on, a particular part of your code, I can bop in there, mess around with it, see what you're doing, or you guys can, follow me along and see some files that I'm working on. So that's super cool, and I think we're able to throw it all in this drive, which I'm also going to throw this in here. And y'all should have access to all of this. Cool. So with Bobby and X, I think we started with kind of going around the room and talking about, we got Inception. Talking about, I guess, one practical reason why you want to get familiar with coding, then one kind of pipe dream. I think for me, the practical reason is just its utility, really, no matter what industry you're in, and looking good on a resume. And pipe dream would probably be doing something in the metaverse. So we'll see what happens there. Colin, what about you?
So yeah, as someone who works in tech, being able to understand code, not just at its textual level, but how it applies to business practices is huge. So being able to understand code to set a foundation helps the pipe dream of, if you're doing analyst work, if you're doing client-facing work, still having utilization and knowledge of those technologies really helps career.
Branson, you want to go ahead?
Yeah, I just quit my job and branched out, started doing my own thing. So this would be super helpful. I'm actually in the process of building a website and a few websites actually. And so this is something that I was teetering the idea on, and then happened to text me. So that aligned perfectly. I think it'll be super helpful with where I like to take things. It's going to be a lot of web-based work. So instead of paying someone to do it, I like to do it on my own, know the ins and outs, and not rely on someone to fix an issue that I have.
Mr. Lawton?
Yeah, like you say, just kind of more recently been thinking about the utility of it, and I'm an environmental science guy for Branson and Cullen, and like you say, it's relevant all over the place. It'll especially be relevant there too within analyst stuff, analyzing different trends or energy trends and energy efficiency, blah blah blah. Could go any way, but I also just know that I'm pretty ignorant with coding, and want to try to change that. Like you say, Carter, make myself a little bit more marketable. Yeah.
Sweet. Pops?
This is a really serious crowd, Carter. These guys are.
You don't know them too well.
So, yeah. And my true confessions is one of our businesses, this is what they do, and I have no idea what it is. And so I need to be able to talk to these guys.
Fair
A
enough.
pipe dream is oh shit, a pipe dream would be, I don't know, maybe one of these days they're short on, they need some help on one of the projects, and I'll say, hey, I know Python. Or ignition, right? That's
Yeah.
the other one.
So Ignition is based in Python. So yeah,
See, I'm halfway there already.
you're right.
Half of the stuff that I do is like being able to talk the bullshit. So it's not. I just have to. There you go. So that's why I'm here.
Well, if that's the only reason you're here, you got to pay me. The rest of y'all still got the
Bullshit. I've been paying you all your
$3.99
life. So
damn. All right. We'll call it even. All right, cool. Yeehaw. We're gonna start out with hardware. You got the CPU, obviously. That's where the magic happens. Oh, is my screen presenting? Hang on. And here we are. Can y'all see that?
Yeah.
Good?
Yep.
Okay. Oh shit. So CPU, I think there's something like every 2 years it doubles in speed. I forget what that's called, but there's whoever found that ratio, that he gave it his own name, and it's called like the something curve. But basically that's gonna keep going. It should hit a plateau somewhat soon, just because we're pretty much at the limits as far as how small that we can get. And there's quantum computing, which is kind of hocus pocus, but Google has actually, a couple years ago, got something called quantum supremacy. And what that means is they're just so far ahead of any other supercomputer. Basically, they ran a calculation that took 200 seconds that would have taken IBM's Watson 10,000 years. So just the mismatch between quantum computing and classic CPU, I mean, it's incomparable. But as far as like, desktop and, laptop, tablet applications, we're not going to move away from the traditional CPU. As a Netflix box and doing some Python here and there, it pretty much does what we want. RAM and ROM. Does anybody know the difference between these and would like to take a crack at it? If not, that's okay. So RAM is the short-term memory, and basically it's all flash memory, which means it's like the same as a flash drive. So it can only run when it has power, and that's kind of the fatal flaw of RAM. It's super fast, super efficient, and you can have a lot of storage on it, but if you're not plugged in and you don't have power, you'll lose it. It's gone. So those ones and zeros only exist as long as it has electricity to it. ROM, on the other hand, is like your classic hard drive, and it actually pretty much used to just be like 5 CDs stacked on top of each other. That's how you can think of it. Now we're moving to solid state drives, which they don't move. They're solid state, and unlike RAM, you do not need power to run them. And I actually lied. Flash drives are like ROM. They are not like RAM, because the data stays on it when you take it out of the computer, right? If a flash drive was RAM based and you took it out, it didn't have power, poof, it's gone. Graphics card, if you're doing any sort of like 3D modeling or gaming, you need one of these. People that build their own computers, this is one of the most important parts, especially if they're gamers, and the supply chain is really messed with the graphic cards. Your monitor or display, obviously that's where the user interface happens. That's where you navigate. That's where you touch the back end, which is all of this stuff. So here is, how much time we got? 6:14. Here's a short video. Y'all can go back and watch it if you want. It just, has a 3D visualization of all of those things. All right. And here is what data is split up into. So the smallest unit, can you all see this okay? Wondering if it's too small.
Yeah, can you make it a little bit bigger?
Yeah. It is a little fuzzy too, so that's not helping. But the smallest unit is a bit, and basically that's a single 1 or a 0. And that can exist on RAM, ROM, flash drive, cloud, you name it. There's something called a nibble, which I didn't know existed. Apparently that's 4 bits. I've never heard of this. You probably never will either. Yeah, pretty sure it has to do with a play on the words with byte, because you get a nibble smaller than a byte. One second. Shut up, dog. Lauren. So this dog is deaf and she barks, which doesn't make sense because she can't hear where it's going, but she likes to bark sometimes. So we got the byte. That's probably the most divisible unit of data you're ever going to hear about. It's 8 bits. So 8 bits. God damn it. Sorry. Can y'all still see my screen? Yeah. Okay. So 8 bits is a byte, and that can hold, I think, 256 numbers and most characters. So when you get to a byte, you can kind of start to work with stuff. When you're just at a bit that's 1 or 0, true or false, you're not going to do much with it. Kilobit, don't really hear about. Megabytes, you do hear about. Then you get to the gigabytes, that's probably like your computer storage. Terabytes might even be computer storage nowadays. Then we go all the way up to a yottabyte, or as X like to call it, a yottabyte. And yeah, I had never heard about that either. But this YouTube video is pretty cool because
computers,
it will give you an idea of how big these things are. And if it's like refreshing or you guys aren't hearing well, let me know, and then we'll just like watch the video individually, like if it lags trying to stream it.
today can hold a lot of information. The terminology can get confusing. Gigabytes, terabytes, and what's a petabyte? Let's start at the beginning. This cube here represents the smallest piece of information a computer can hold. It's called a bit. It stores two different states or values. You can think of this as a true or false, on or off, yes or no. But most commonly, it's thought of as a 1 or a 0. Now let's add another bit. By changing these two bits to different combinations of 1s and 0s, we can now store 4 different values: 0, 0, 0, 1, 1, 0, and 1, 1. This is how you count from 0 to 3 in binary. Now let's add another bit. You can store 8 different values now. Each time you add a bit, you double the amount of information you can store. Once we get to 8 bits, we group them together. This is called a byte. It can store 256 different values. A byte is also enough space to store a single character, such as a letter, number, or symbol. Add more bytes, and we can store larger numbers, colors, and we can even put many characters together to form sentences. We're going to need a lot more bytes to store something useful. When you have 1024 bytes, we call this a kilobyte. Now you might ask, why the 1024? Why not 1000? Hang tight, I'm going to talk about this towards the end of the video. A kilobyte is enough space to store a small text document. To To store a low resolution picture, you're going to need somewhere around 100 kilobytes. Once you get to 1024 kilobytes, we call this a megabyte. 1 minute of MP3 audio is about 1 megabyte. Those old 3.5-inch floppy disks can hold 1.44 megabytes of information. A high-resolution picture can be around 5 megabytes. A CD can hold up to 700 megabytes. 1024 megabytes is called a gigabyte. A DVD can hold up to 4.7 gigabytes. A Blu-ray disc can hold up to 25 gigabytes. A flash drive today can hold 32, 64, or 128 gigabytes. They'll probably have something larger by the time you watch this video. 1024 gigabytes is called a terabyte. A hard drive will be anywhere from 1 to 8 terabytes. 1024 terabytes is called a petabyte. Web servers for companies such as Facebook, YouTube, or Amazon will be measured in petabytes. 1024 petabytes is called an exabyte. The amount of internet traffic every month will be measured in exabytes. After exabytes comes zettabyte, and then yottabyte. Well, you get the idea. So big.
All right. Did that come through all right?
Yeah, that's
Sweet.
good.
All right, there's your data structures. That kind of bleeds into binary numbers. There's another YouTube video here. If y'all want to watch, it's just kind of visualized and breaks it down a little bit. But I guess simply put, binary back up. Our decimal system is base 10, which means once it gets to 10 digits, which is 9 here, but we got the 0, so really 9 is the 10th. That's when we restart and we bump over and we have the 1. Binary is just 2 digits. So once we get to 1, we can't go to 2. We gotta roll the 1 over. So basically 10 in binary is 2 in our decimal system. 11, we can go up to 11. That'd be 3. But once we get to 11, we can't do 12, so we got to do another 1. So 100 in binary would be 4. So that's kind of how that works. I mean, it goes all the way out, and really it's this is just one representation of binary. Like if you're trying to store a number from binary, this is what it looks like. But characters will have like corresponding binary values to them, just depending on what data type you're looking at. And there's something called hexadecimal, which you'll run across occasionally, and it's basically a base 16. So we get 0 through 9, that's 10. Then we go A through F is 6, so we have 16. Encryption tools, they'll use hexadecimal just because it's harder to crack than our base 10. And 16 is like somewhat manageable as opposed to 26, which would be our alphabet. Cool. As far as some languages go, we're going to go with Python. Why? It's the most popular. It's very easy syntax, and syntax is a vocab word. And there's probably a better definition of it, but to me, the different way that languages achieve logic. So you can think about it like Spanish to English would have different syntax of like how to pair a noun and a verb, right? So like Python and Java and C, they're all going to look different if you're trying to do a loop, if you're trying to do conditional statements, or if you're trying to make a function. Yeah, it's very readable. So some languages, like, it's very hard to decipher, especially because some languages require that you have brackets and semicolons. Python doesn't have that at all, but the spacing is very important. So if you have like a conditional statement, like if you say if something, then you want to put you're then basically a tab over. So rather than having brackets, which is what 90% of languages do, you're going to have to pay attention to the spacing. That's something we'll get into later. Some other languages, just randomly: Java, C++, C#, VBA, HTML, JavaScript. These last two are pretty web development based. Another one would be PHP. And Java, C++, C#, more like back-end development. VBA is Visual Basic, and I'd say, like, I don't know, a lot of software applications, especially Windows ones, are programmed with this. And this is another cool video y'all can watch at some point that basically shows over time the popularity of programming languages. And basically, like the 80s to the 90s to the early 2000s, C really took over. In the early 2000s, Java took over. And really, in the past couple years, Python has become the most popular language. So, good skill to have, because that's what the most people know that are programming. This is something that came up in the last session. By the way, if y'all have any questions, let me know, and we can make a new slide, throw an infographic on here or something. But the difference between JavaScript and Java. So JavaScript is interpreted and Java is compiled. The difference between interpreted and compiled is basically interpreted, or if you compile a program, it's basically an intermediate step to execution. So you have the program that you write, and then when you want to run your program, some languages will just run it and you get your result. But a language like Python or Java or C, you have to compile it first. So it goes into a compiled version, then you can run that compiled version. So that's something to keep in mind. The thing that we use, even though Python, you need to compile it technically, you won't have to worry about that, because Google is our overlord and takes care of those things. There's a difference between object-based and object-oriented. I don't know that off the top of my head. Then this is pretty important. So in JavaScript, well, that won't make sense. We'll get to that in a little bit. Here's kind of the random tangent, but disciplines that have to do with coding. One of them touched on earlier, 3D modeling, and that's more front end. I don't know how much coding you're going to touch if you're doing pure 3D modeling. You know, if you're trying to attach it to some sort of functionality, like in an engine called Unity, which is where game development is made, you're not only going to make that 3D modeling, you're going to connect it to the brains of the bunch. Something that pretty much everybody is going to touch regardless of the industry is databasing, and the language you use to this is called SQL, and that's just a standard way of accessing databases. They call them search queries, and depending on what you type in, it spits out what you want. An API is pretty cool. This isn't really a discipline, but it's a part of web development. Essentially, if you have a website that's spitting off data, it's in a common format called API, and it's basically a big array, and you can have a custom script that pulls from an API and get it to do something cool. And there's web or phone development. This is more front-end stuff like Branson was talking about. There's a lot of web builders out there that make it pretty easy, but knowing the back end is really important in terms of getting it to talk to databases or getting it to do exactly what you want it to do. The back end development it's really kind of like the jack of all trades. Like, if you can handle this, you can handle most other stuff. And learning any languages from scratch is essentially what you're doing. Another big one is cloud development, AWS being the big player. I think this touches a lot of industries, and learning how to use it is definitely going to get you a job. And another emerging industry is cybersecurity, and this really touches a lot of things, and it's just going to keep growing and being ever present. So some more vocab. Full stack developer is being able to integrate from the back to the front end, just kind of a jack of all trades. UI is a term you'll hear me use, or GUI, GUI. That's just user interface. So it would be like this PowerPoint. It would be your iPhone screen. It would be an app screen. It's basically what the user sees and interacts with. GPU. So the other slide, syntax, we talked about that. Cool. So data types. We have characters. Oh, we also have booleans. So these are descending order in terms of how much storage they are. So a boolean, literally just true or false, 1 or 0. It is a bit. A character, I think like the video mentioned, you can, oh sweet, here's X. Yellow. I think you're muted.
What up?
What up? We're just
Hey,
wrapping
Ron.
up on the session 1, and then we'll hop on to session 2. Colin, I don't think you've met X. X, this is Colin, my buddy. I think everybody else is acquainted.
Yeah, I just want to say that I'm
Sure.
not sleeping.
Oh, look at that. Big man.
He's talking about you, Steve. Branson, what'd you say?
I said I'm not asleep. I'm just frozen.
Oh,
I've been
okay.
looking at my look like I'm asleep over there, but I'm just frozen.
You're good. I can tell that the eyes are open. That's all that matters. So we got characters, then integers. Most of the time when you define an integer, you're going to get up to 32,000, negative or positive. You get an integers or whole numbers. So 1, 2, 3, 4, and nothing in between. No decimals. If you need something with decimals, you have floats. And basically that can handle decimals, but it takes a lot more data. So if you're constrained on your memory and you don't need floats, use integers. But for most purposes, you're good to go with a float. Then we have strings, which these two can probably be switched. Strings are a string of characters. So just anytime you need to use words, mind you, you can use numbers that are defined as strings, and that's where this data type and mismatch is really going to become prevalent for you. A lot of your time is going to be debugging types that aren't working. So for instance, you could be working with a string and then need to use it as a number, but if you try to divide like a 1 that's stored as a string, it's just not going to work. Like that's basically letters. The computer thinks it's letters even though it's a number because it's stored as a string. But Python is really easy to switch data types. So that's something that Python definitely excels in. Other languages have very particular and sticky syntax to try and switch data types. So that's just something to be aware with. An array is a sequence of a particular data type. So you could have an array of names, and in that array of names, you could have Stephen, Branson, James, Colin, Xavier, Carter. And you could index that array and pull out particular names, depending on what you're looking for. And you can iterate through that array. So, yeah, that's it for now. And now we have Google Colab. So, like Google Docs, and it has this thing called kernels, which we will get to. If everybody could go to the drive and then open up coding session 2, or just follow me along, we'll go from there. X, did you get access to this folder?
I'm double checking to see. I think you sent it the first time. Let me see. I don't think so.
Okay.
Oh wait. No. Well, I see the notes, but that's it.
Okay. Where do you share? Here we go. All right. You should have gotten a link.
Doink.
Cool. So this is something that we messed with last time. I was just kind of messing around, having Bobby and X follow along. Do y'all have any questions at this point? Nope. And what you guys can do is when you have Google Colab open, go ahead, go to File and New Notebook. Go ahead and make a new notebook. That way you guys have something to work with. Just name it whatever you want.
Vulgar language.
Oh yeah. So, again, this is like a Google Docs. So all you guys can see, but it's different than Google Docs because if I do something, you're not going to see until I save and then you save. So be aware of that. It's more of like a file transfer than a follow along. And the reason is because when you're running a script in Python, it's got to like connect to something called a runtime. And because of that, it can't automatically push updates like a Google Doc does. But what makes Python so unique is every other language, as far as I know, you just have your code. And you click go and it runs. What Python does is it has this thing called kernels. And kernels are little blocks of code, which you see right here. And basically, you can run it in any particular order that you want. And that may not sound like a lot right now, but it is super helpful and it's going to save you a lot of headache. So being able to iterate through your code like this, being able to change the order of it, this, that, and the other is just super helpful. Cool. So I'm going to go to coding session 2. All right, we're going to talk about inputting variables. Now, this is pretty specific to Google Colab. There are other ways to do it if you're trying to run Python on like terminal or your own custom application. But for our purposes, this is how we're going to do it. So on your new Colab sheet, I want you guys to add a form field. Basically, how you do that is you go to the Insert tab and click Add a Form Field. I want you to leave the input the same as far as field type. Leave it as input. The variable name, you can name it whatever. Then the variable type, let's leave it string for now. Cool. Give me a thumbs up when you got that, or let me know if you need some help. Alrighty. Everybody get that? Yes, no? X, did you open a new workbook? You're muted.
Yeah, I did.
Okay. Do you see the insert tab?
Yeah.
Okay, go ahead, bop down and click.
Add a form field. Oh, I see what you're saying.
You got it?
Yeah, I got you.
Cool. Again, we can call this whatever. And we're going to leave it as a string. And once you have that, you're going to click save. Lawton, were you able to get that? You're muted.
I'm still navigating over here. All right. Yeah, I'm with you now.
Word and Colin? Good.
We
Sweet.
got no.
All right. So now that we have our input, and it is a string. That looks a little funky.
Ops is out.
Oh, okay. Good. Now we can talk shit. All right. So basically, this is called a form field, but if you were to use something called, your terminal, which eventually you'll get here, basically you would like run a Python file. No more talking shit. And then when the Python file is running, you can input something to the program. So this just makes it a little more user-friendly and a little bit more readable. Again, that's one of the benefits of Colab. So what we're going to do is something super basic. We're going to insert a variable. We'll say we're going to call it Hello World because your first program is always Hello World. Then down here, how we're going to spit it out. Let me zoom in on this. Come on now.
Oh, that's what we did last week.
What we're going to do is we're going to say print. Then we're going to have parentheses. Then in those parentheses, we're going to write whatever our variable is. And I can't spell, but there we go. So once you have that, if you just click this, you're going to get an error. Why? Because it's split up in two particular kernels. So you have to run this one first, and that spits the hello world into here. Then we can click this, and it'll actually print what's in the variable. So we got hello world. And again, you can see it all right here, so it's maybe not as cool as from the terminal or something. But this is your first program. You're defining a variable, then you're getting it to spit out. Does anybody have any questions on that particular spot or have any hiccups?
Oh, yeah. The dang capitalization.
Yeah, so that's a very good point. If I were to capitalize it here, we're going to get a name error. Or if I were to capitalize it here, I'm going to get a name error. So something to always be aware of is not only your spelling, but your casing. And there's a couple different ways to write out variables because you're going to get to a point where like one word variables just aren't going to cut it because you're going to have too many. I mean, by all means, you can do something like this. You can define your variables as A, B, C, D, or X, Y, Z, but at a certain point, you're just not going to be able to keep up with what's what. So I forget what it's called, but there's some like standard that basically says that the more I guess, worded out your variables are, the better. And that's going to help you. It seems kind of dumb. You're like, oh, I can keep up with what's doing what. But, spell it out as much as you can. So, two different ways to spell out variables. One is called camel casing. And that's basically where the first letter of your variable is underscored. Then from there on out, the first letter is capitalized. So that would look like this. And that's an error. Or you can do something like this, where you can say this variable, blah. So it's really user preference. I kind of like the camel casing. The underscore definitely spaces it out a little bit better and makes it more readable. So do as I say, not as I do, right? But either way, just make it readable, see what you like, and go from there. So we've kind of touched on defining variables, and something that's really cool with Python is when you're printing, it doesn't have to be a string. And remember, I was talking about the data conversion types. Like if you were doing something like Java and you had so again, this is a 0, but because you have these quotation marks, this variable is going to be a string. So I guess the downside of Python is because it kind of cuts corners in the syntax, it could be a little bit of a hurdle, like picking up initially. So anytime there's questions, stop, let me know. What I'm trying to get at is other languages, you really have to specify whether you're using an integer or you're using a string. You have to even say like variable integer, this number equals 0. So it's kind of redundant, but it kind of lets you know what you're doing a little bit better. But with Python, when you're defining a variable, you just literally have to say you just have to put it and do that. Set it equal to something, right? But really the only couple distinguishing factors is when you're using a string, make sure to use quotations. When you're using a number, just put it in there. When you need a float, put a decimal. So say we wanted to do something like we want to add this string and this number. What's going to happen?
Wait, if you put it in another line?
Yeah, like if we were to say this string plus this number, we have to do it backwards. So this string plus this number equals this, or we'll say result rather. So just like initial reactions, what's going to happen right here?
Be 1.
Well, it's kind of a trick question. Why won't it work?
No parentheses.
What do you mean? Oh, like right
you
here?
put variable name in parentheses up top.
Oh, like
It's
right
kinda-
here?
No, up. Not quotes. Parentheses.
Like here?
Yeah, like are you supposed to put no, like on the ones, the parenthesis before the V and the parenthesis after the E.
So you can ignore those two top ones. Only working with these two. So say we just start a program and we define these variables up here. Then okay, got 10 minutes, perfect. No, I don't want to do that. So, all right, again, it's a trick question. The reason why it's not going to work is because you're trying to add a string and a number. So it just doesn't like that. So basically the computer, it might as well be reading it as a plus 1. It's like, can't do that. But if you were to say this number, that number, and you were going to add these two, well, got to redefine them. Then it's going to work. We can go a step further, and we can say print result. We're going to get 1. So, again, the reason that the original one didn't work is because if you try and add a string and a number, it's not going to work. And I think if you even try and add a float and a number, oh, well, Python took care of that. I'm guessing it, yeah. So when you add a number, meaning just an integer, and a float, meaning a decimal, Python's just going to default it to a float. So that's the whole kind of being careful with data types sort of thing, because you can just get caught up and forget what's what, and it's all about making it, talkable to each other. So something else you could do here is, like, say you had this string equals 1, and again, this isn't going to work because you're trying to add a string and a number. But something you could do, and this is also what makes Python pretty cool, this is called type casting. And it's basically making a variable a different type of data. So if you do this, it should work. And I lied.
Is int integer?
Yeah.
Is that
exactly? So basically, when I throw this in front of int, it'll pop out like that. And another thing we can do is we can go in the reverse direction. So we can do something like string this float. Maybe it's toString. I don't know. There's a way to cast it back. So it's something to keep in mind. And at the end of the day, it's as quick as a Google search. It's your best friend. There's no reason to memorize every syntax of everything when you can type it out and have the answer right at your hands. So, any questions so far? Any observations, thoughts, concerns? Nope. Okay. We're going to move on. We talked about inputting the variables. We talked about printing the variables. And while we're here,
you sure are not sitting that close to the TV.
Well, I got this somewhere.
Here.
No, you're good. I'm gonna sit down close to the TV.
Dude, no, that is terrible for your eyes. Sorry, y'all.
Blue light.
I didn't realize I was off mute. Ryan's trying to sit this close to the TV. I mean,
that's like a 120-inch screen if you're that close. Life hack.
I gotta get my directory right.
Oh, man. So another way that you can use the print function, if you do not want to get off my screen.
You look like that.
That's kind of mean.
hey, we have 7 minutes.
7 minutes left.
Yeah, because it's free.
Sorry.
So what you can do is in these print functions, you can put your own strings, and then when you run it, it'll just spit it out. But this can be pretty helpful because you can put like string, comma, result, and then like if this is helpful, just know that. So basically, you can put like a front runner and saying like the result is, and then spit it out. And if you have like hundreds of things spitting out, it makes it a lot more readable. Because, I mean, at the end of the day, you're trying to get outputs. So that's the print function. Then printing variables continued. So the difference between putting a string in your print function versus printing an actual variable is right here. So last thing to wrap up today, we're going to talk about conditionals. So every language has its own syntax for this, but Python's looks like this. Basically, we'll say var as in variable equals 1. And we're going to say if var equals 1, mind you, random tidbit of programming, anytime you have a conditional and you're comparing something, you do a double equals. I don't know why that's the case, but that's how it is. So if var equals 1, we're going to print the var is 1. Remember I was talking about the spacing right here? This is where it comes into play. So if you have a conditional, the thing that you want it to do if you meet that conditional, you got to push it over a little bit. So we got if var equals 1, print this is a 1, else we're going to print done goofed. When we run it, we're going to see this is a 1. Why? Because right here we said var equals 1. Went to here. All programming just goes line by line. So we go to here. If var equals 1, it does. We're going to print that. We go up here and we say var equals 2, and we done goofed. So that's very simple conditionals. Something else you can do is something called an else if, which in Python it looks like that. So we can say else if var equals 2, we're going to say
I did it. Nice.
this is the 2. Then right now var is equal to 2. This is the on 12. Weird. 2. This is the 2. Cool. Something else to note about conditionals is, got 3 minutes. Whenever you meet the condition, it cuts out right there. So when the var equals the 2, it looks for where the else, or it looks for the end of these conditional statements, and it just bops to there. So if you want something to happen, then you got to put it after the conditionals, right? Because var equals 2, it's going to go right here, then it's going to go right here, then it's going to skip this completely. So one of the very common debugging errors you're going to do is your conditionals are just slightly wrong. Because the program, it's always going to do exactly what you tell it to do, but sometimes, you know, for this reason or that, you just write it a little wrong. And that's what debugging is for. And that's 90% of programming. Fellas, that leaves 2 minutes. So I'm going to open the floor to any questions.
So on that, the var is 2, the elif, could that line extend? Could there be other, could that line go deeper?
Yeah.
On the print. Oh, okay.
You could also say,
No, I'm talking about the.
Oh, this one? Yeah. So down here, you could say var equals 5. You know, so basically, if var is 2, var is then going to equal 5. Then down here, outside the conditionals, we can reprint the var, and it's going to be 5. Or we can say var equals 1 and run it. So it's going to go here, here, here. It's not going to go there. The var is still going to be 1. So, oh well, meeting ended. Thanks for joining.